Hello all, Jeff Morford once again. I'm seeing if using a Zoom meeting but only inviting myself and recording it is a reasonable way to work out some problems in math. And if it works out, I'll share it with everyone. One question that you're asked in section 6.1 of Math 131 is to find the standard deviation. That's how spread out the data is. If you look, this data right here is not very spread out at all. The numbers are at most 1 or 2 away from 6, and so we're going to expect a fairly small standard deviation, but let's talk about how we can exactly calculate that. So the first step is to find the mean, and the mean is the sum of the data divided by the number of data. And if I add these up, 4 plus 5 is 9, plus 6 is 15, plus 6 again is 21, and then we've got 15 more to add here. So the sum turns out to be 36 divided by 6 gives us 6. That's the first step of finding the standard deviation. For the next two steps, it's easiest to make a chart where you list your data and you subtract your mean from the data. I'm going to use the Greek letter U to represent mean, just like the book. And then the third column is you square that result you just got. So whatever you get when you subtract the mean, you square it. So our data are 4, 5, 6, 6, 7, and 8. From each of these, we're going to subtract 6. And when I do that, I get -2, -1, 0, 0, 1, and 2. The next step is to square each of those numbers you got. After this step, every single number you have should be positive. If you get a negative, it maybe means you forgot to put parentheses in on your calculator. So for instance, -2 times -2 is +4, and -1 times itself is 1. If you multiply 0 by itself, of course you get 0. And then 1 squared is 1, and 2 squared is 4. So now we're through 3 steps of calculating the standard deviation. What we're going to do next is take the average of these squares. So we squared because if we were just to add these up, we'd get 0. So the average distance would be 0 if we kept in mind whether the numbers were smaller or larger. By squaring, we've made them all positive, but now we want to know a typical distance away. So if I take the mean of these, I would do the sum of the data divided by the number of data, 6 again, and this is 10 over 6, or 5 over 3. The last step is to kind of undo the squaring by taking a square root. So the standard deviation, which we usually denote by the Greek letter sigma, would be the square root of 10 over 6. And before I started the video, I took that square root, and that turns out to be 1.29. So this says that the typical number is 1.29 away. And if you look, some of them are none away, some of them are 1 away, some of them are 2 away. So typical distance away does seem like it should be around 1, and that's what we got. So it looks good. I'm going to stop the recording, see how this turned out, and if I like it, I might share it. If I don't like it, no one will ever see it.